So what we're going to look at in this video is 3 examples of questions that we could see related to our transformations. So the first thing I'm asking you to do is to draw this rotation around the origin of 270 degrees. So what I want to do is to figure out what my new points A prime, B prime, and C prime will be by figuring out what happens to A, B, and C. So the first thing to know is that whenever I have this transformation, this rotation happening, my point X and Y gets transformed into Y negative X. And that's something that was in our last video and is in our notes. So if I have a 270 degree rotation around the origin, my point X and Y will become Y negative X. So let's take a look at the coordinates of A, B, and C. And let's figure out what happens to them to become A prime, B prime, and C prime. So the location of A is negative 5 and 2, 4, 6, 8. So negative 5 and 8. The location of point B is 3 and 3. And the location of point C is negative 3 and positive 3. So what happens to transform these into A prime, B prime, and C prime? So let's figure this out. So my point, my X and my Y should switch places. So I should have 8 becomes my new X, and then I have a negative 5. So that actually becomes a positive 5. My value B prime, I have 3 and then a negative 3 because the X becomes negative. And then C prime is 3, and this becomes a positive 3 because I have a double negative again. So let's plot these 3 points. My A prime is over 8 and up 5, so 2, 4, 6, 8, and up 5. Okay, that's my A prime. And my next one is 3 and negative 3. That's going to be B prime. And C is 3 and 3. So I actually end up with a little bit of an overlap here. So what does that look like? I'm going to draw a nice little line here. Oops. There we go. So this is my new shape. So you can actually see this rotation. It's around this point, the origin. You can see that our shape has been spun around, so it's not facing the same way anymore. It's been rotated. All right, let's take a look at another example where we're asked to do a transformation to our points, and I forgot to label them. We'll call them A, B, and C again. So that's A, B, and C. And we're translating it. Okay, so we have a translation of negative 1 and 0. So we'll follow the same steps again. We'll figure out what our A, B, and C are, and then we'll figure out how to transform them. So we have A is at negative 5 and 7. My point B is at negative 2 and 2. And my point C is at 2, 4, 6, 8, negative 8 and 2. All right. So what happens to my curve when I have this translation happening? So I have A prime. And what I'm going to do is follow that rule that if I have X and Y, I have X plus A as my new X value and Y plus B as my new Y value. So my X is negative 5 plus a negative 1 because that's my value of A. That gives me a negative 6. I have my value of B as 0. So 7 plus 0 is still just 7. B prime, I have negative 2 plus a negative 1 gives me a negative 3. And 2 plus 0 again is just 2. Negative 8 plus a negative 1 is a negative 9. And then we have 2 remaining the same. So what does it mean whenever we have our value as B as 0? It means our Y values will actually stay the same. So our graph might move to the right or left, but if our value of B is 0, it's not going to be moving up or down. So let's take a look at our new points. I'm going to have to erase a little bit of lettering here. We're going to plot our new points. So negative 6 and 7 for my new value A. Okay. I have negative 3 and 2 for my new value of B, and negative 9 and 2 my new value of c. So that's c prime, that's a prime, and that's b prime. So what ended up happening? My graph, woo, that totally didn't connect, but anyway, we'll pretend that it did. My graph has moved one space to the left, and that makes sense because we know that a changes the placement of our x value. All right, let's take one more example, and we're going to actually try to figure out the transformation rule that associates these two figures. So we have our original figure here in blue, and we have its image in red. And what we're going to do is just to start by writing down the coordinates of a, b, and c, and then a prime, b prime, and c prime. So a is at -9 and -1. B is at -2 and -8. And C is at -9 and -8. We'll take a look at the image. A prime is at -1 and 9. B prime is at -8 and 2. And C prime is at -8 and 9. So we're trying to figure out what actually happened to our x and our y. So if each of these points has an x and a y, what ended up happening? Well, the first thing that we notice is that our y is now in the position of what used to be our x. So we can see that they switched in their placement. So we now have a -1 where for the x value when it used to be our y. We also have the same value for our x, except now it's become negative. And we can double check that this works for all of them. So -8 becomes our x, that works. And -2 becomes a double negative. So a -2 gives us a +2. Let's check our value c. So our y value -8 is now our x value. That works. And this -9 now becomes a -9, so it gives us a +9. So that ends up working. So what I need to figure out now is what type of transformation takes a point x and y and changes it into y and -x. So if we look at our notes from before, we actually have rotations that do this. So what rotation causes this to happen? Well, we can write it down two different ways. We can say a rotation around the origin of -90 degrees. Or we can also say a rotation about the origin of a +270 degrees, because these two are actually the same thing. So this would be our final answer. This is the transformation rule, or these are the transformation rules that associate these two figures.